All right, number 12 is about simple harmonic motion. They give you a graph of displacement versus time, and there's two different curves on it, so there's two different examples of simple harmonic motion. So for each part of this problem, you'll have an answer for A and an answer for B. So part A here, let's say A, B. I'll answer it like this in columns. Part A, they say, what is the amplitude? Amplitude on the displacement versus time graph like this is the distance away from zero that each peak occurs. So it looks like for the purple curve, or curve B, that's maybe 3.5 meters. And for curve A, the red one, looks like maybe 2.5, somewhere around there. You could also go down and measure it down. But what you don't need to do, which is a common mistake, is measure the distance from trough to crest. That distance will be twice the amplitude. That's not the amplitude. All right, B asks for the frequency. It's not straightforward to read the frequency from this kind of graph. It could be if the numbers were nice, but frequency is number of cycles per second. So it might be easier first to find the time period and then remember that frequency is 1 over the time period. So the time period for A looks like exactly 4 seconds. From here to here, that's one cycle, that's one time period, so 4 seconds. So the frequency would be 1 over 4 hertz for A. For B, it looks like the time period, from this point to this point, that's 2 seconds. So T equals 2 seconds. So the frequency here would be 1/2 hertz. C asks for, time period. Well, that's a little misleading. I think it's probably easiest to find frequency by taking the reciprocal of the time period. So we've already answered C. Time period for A is 4 seconds. Time period for B is 2 seconds. D, they want you to write equations for both curves in the form of either a sine or cosine. It's easiest for curve A if you pick the one that starts at 0, which is sine. So the displacement as a function of time will equal the amplitude, which is, I call it 2.5, times the sine of 2 pi over 4 times t. All right, and the reason I know that it has to be that is sine and cosine both have amplitudes of just 1. So if you're trying to fit this red curve with a sine curve, you've got to multiply on the outside by the amplitude. Then on the inside, a sine and a cosine graph both have set periods of 2 pi radians. But our x value, or x-axis, is time in seconds. So we have to convert the normal period of a sine curve to our period on this simple harmonic motion for curve A. And the way that you convert that is by multiplying by 2 pi over 4. The goal being when t gets to the value of 4, the 4 here and the 4 here will cancel out, and you'll be, the inside of these parentheses will be 2 pi, which is where sine starts over. And you should have seen this in math, but it's a way to adjust the time period for a sine or cosine curve. For curve B, x as a function of time will be B amplitude, which is 3.5, and Curve B starts at a maximum, so that's going to be cosine of 2 pi over 2 times the time period, which simplifies to just pi times the time period. If that last part is confusing, I would say that you need to review how you shift and transform trigonometric graphs.